So do let me know if you can hear me out. We will start the session in exactly 15 minutes at 8:30. And in the meantime, please do introduce yourself. Do let me know about your background, if you already work with Kubeflow or if you work with Kubernetes, or if you have any specs, you can say particular expectation from the session. We will be talking about Kubeflow, and I hope you all have the agenda with you from the events page. But in the meantime, please do introduce yourself. Do let me know about your background. What do you work on? Which clouds do you use? Which programming languages do you use? And please do introduce. We'll start the session in exactly 15 minutes. Everyone, please introduce yourself. Do let me know about your background. From where are you joining in? Where do you, what do you work on? Which technologies? What's your, a little brief about your background, your job description as well. Anything you want to share which is relevant for us. Anything like that? Do let us know about yourself. We'll start the session in around at 8:30, right? We'll start at 8:30. So those who have just joined in, please do let me know about your background. What do you work on? From where are you joining in? So today we'll be having the session on Kubeflow. Do you already work on it? Or do you work on Kubernetes or machine learning, AI? Which programming languages do you use? Uh, which type of neural networks are you aware of? What have you worked on before? Which clouds are you are familiar with? Which clouds? Any information about yourself? Please do introduce yourself in the chat window. And we are live on LinkedIn. We are live on Facebook and on YouTube as well. Now, sometimes what happens, the stream quality on LinkedIn Live automatically, you can say, comes down. So that is something which we have seen during the previous sessions. So in anything, if anything like that happens, please switch to YouTube stream. YouTube stream is of pretty good quality. And the link of YouTube stream is, you can find that link from the events page. It is already posted over there a few hours back. So please take it from there. Okay, so everyone who has just joined in, please do introduce yourself, and we will start the session at 8:30. Right? So do let me know about your background, what do you work on, anything relevant as such, and what are your expectations from this session. And also let me know in future if there is any particular technology you want us to do webinars on. So we regularly do webinars called as Tech Edge series as part of Tech Edge series, and where we cover the any latest technology as such, or anything which is going to be something very big in future, and which is something which you should be aware of, and where you can strategically invest your time into learning that particular technology. So as part of the Tech Edge series, this is the session on Kubeflow. So do let us know in future which sessions are you looking for. We already have sessions planned on MLOps and on Kubernetes as well. To find more about these sessions, please join us on the Tech Scalable company page. We regularly, you can say, put post over there over various any new technology which comes out, any updates which are there. Informative posts are there. We have information about the upcoming events as well. So please join us over there. We will start the session at 8:30. So please hang in and do introduce yourself. So we will start the session at 8:30 in around in less than 5 minutes. So please to introduce yourself and do let me know about your background, any expectation which you have from this course, from where are you joining in, anything which you want to share. Do you have you were you part of any of our previous webinars, or maybe you are looking forward for anyone? Then anything like that you can share with me. We'll start in around 4 minutes. So I turned off the display by mistake. I just turned it back on. So we'll start a session in next 2 minutes. Please do introduce yourself. So we will start the session in around another 1 minute. So please do introduce yourself. Let me know about your background. What do you work on? And thanks for joining. Hope you are doing well as well. Okay, so let's get started. And it's already time. How are you guys? So let's get started. Now, what do we have with me over here? Uh, I'll just take a couple of minutes of your time to quickly introduce Tech Scalable, and then we will start with this session. So we at Tech Scalable, we provide services across training and consulting domain. We focus on cloud, DevOps, machine learning, data science, artificial intelligence. In case you have any requirements in the following domains, in case you are looking for training or consulting, you can definitely reach out to us over this number and over that email ID. My name is Shivam Sharma. I'm your speaker for the day, and I'm a co-founder at Tech Scalable. Now, today we will be discussing about Kubeflow, and I'll just quickly put the agenda on the screen. Okay, check this out. So we will be learning why, what, and how of Kubeflow. What do we do with Kubeflow? Why is it there? Why do we need it? How to deploy it? How to train machine learning model with it, and any other information like that is something which I'm going to share with you. So this session is where we will be learning how to install as well Kubeflow. Kubeflow is something which takes a little bit of efforts in installing, so I'll help you with that, the installation guide as well. And let's get started. I'll quickly open the whiteboard, and just give me a second. Okay, now I don't want to sort of you can say I just want to hit the topics right away. And this is my Azure portal, right? And what we will be doing is we have to work with Kubeflow. We have to understand what it does and what the various components over there. How do you work with it? And Kubeflow is a toolkit for machine learning on for Kubernetes. So it basically needs Kubernetes cluster to be there. So we need to create the Kubernetes cluster. Now you can use multiple platforms. You can use GCP, Azure, AWS. You can deploy it on premises as well. But today we will be deploying it with Azure Kubernetes services. So basically we are deploying Kubeflow over AKS, and then we are training one convolutional neural network over it, and we will learn the various components as part of it. That's what we are planning. Okay, So what I'll do, I'll try to keep it as hands-on as possible. I'll try to keep it as descriptive as possible. So what I have done is I definitely have already prepared few of these scripts. I have few demos which are already ready-made, and some of them I'll be deploying them from scratch in front of you. So I will just quickly show you one file. See, so I have few commands here. What we will be doing is we will run the commands first, and then what because some of these commands will take 10 minutes to run, some of them will take 4 minutes to run, one of them will take 15 minutes to run. So because it will take some lot of time for them to run, we will so first we will run it, and by the time they are running, we will talk about that particular thing as such, right? That's what we are planning. Okay, so I'm opening few of the things over here in my laptop. I have this Azure portal opened as well, and I'm just opening Cloud Shell, which is basically a Linux machine in which you are accessing over the browser. So this is Cloud Shell. We needed to run few of the bash-oriented commands, and I have the CLI installed in my laptop as well. Let me see. Let me open this in uh, Run as administrator. Okay. So now I'll just quickly do AZ login there. So AZ login is so what I have done is I have installed a couple of things in my laptop to be able to show you what we are doing. One of them is I have installed the CLI Azure CLI in my laptop, meaning so I can connect to the cloud and I can deploy clusters over there. I can deploy image repositories over there, and I can work with it. That's one thing which I have already have installed. Secondly, I have installed few clients. Like there is a client called as Juju client. We'll see what that it does. It's already installed. It makes life easy. So I'll walk you through that as well. So first thing is, so we have connected to the Azure cloud. That's one thing which I have done over here. And I just want to quickly show you the let me open another notepad, and I'll just walk you through what we are doing. So the very first thing is, because Kubeflow is the machine learning toolkit for Kubernetes, we need Kubernetes, right? So we'll deploy Kubernetes. Now today's session is not really about Kubernetes, but because some of these commands will take some time to run, we will be having few. We will have a quick recap of AKS and so on and so forth, right? AKS is basically Azure Kubernetes Services, which is which is when you run Kubernetes in Azure, it's called as AKS, Azure Kubernetes Services, a managed service. It's like a totally managed service provided by the cloud. So I'm creating one resource group. It's called as Kubeflow CRG. The location of this resource group is East US. And what I'm basically doing in this resource group, I will be deploying the Kubernetes cluster. So let me just quickly rename the files over here. Now, the cluster which I'm deploying is called as AKS Kubeflow Demo Southeast Asia. That's the name of the cluster, and it basically will have two nodes over there, and it's a Linux based cluster, so SSH keys will be generated. So I'll just copy these commands, and let me zoom out slightly. Okay, and I will go back to the let me just quickly go back to the Azure portal. Okay, and let's use the CLI. Let's not use the portal right now. Okay, so I'm just making this cluster. Resource group creation takes hardly few, maybe less than a minute, sorry, less than a second, but the AKS will take around 10 minutes, right? So in the meantime, let's see what we are doing. We will talk about the Kubeflow and AKS and how do they come together in the meantime. So I have this now. Whenever you want to work with Kubernetes, like if you want to work with Kubernetes, like the very first thing is like the cluster comes needs to be there. So we are creating one AKS cluster. It is an two node cluster. Now, if you know about Azure Kubernetes services, the master node is anyways free of cost. You don't have to make it. You don't have to basically manage it. You don't have to make it high available. It's managed by the cloud platform. So one master node will be there at the backend right now. While we are speaking, that's happening, right? Let me just quickly check if the script is running or not. Yeah, seems to be running. So okay, so one master node will be there, and apart from the master node, we have these two other nodes will come up as such. So over here, now you have zero control on the master node. Master node in Azure Kubernetes services is free of cost, managed by the cloud. Customers don't have to worry about it. So something like this is coming up right now. I'll take a little bit of time in drawing these, right? So I'll keep it as clean as possible so it makes more sense, because it may get very complicated very soon, right? So in the meantime, the cluster is coming up. I'll just quickly show you what do I have over there. So when this master node will come up, is this master node will be having few roles inside that. We call them like server roles are there, or the master node roles are there, and there will be one API server will be there inside it. So API server, that's one role over here. Controller will be there. So controller, right? We will also have scheduler inside the master node, right? And we will have HCD. So HCD will be there inside it. Let me write it properly, right? So basically these roles will be there inside the master node. Now, what is the meaning of these roles? What is happening as such? Now the API server exposes the API of Kubernetes. It it caters to those external and internal calls as well. You can reach out to the API server over the kubectl, or you can also have REST clients too. You can over which you can reach out to it. Now, scheduler is basically if any new container needs to be created, scheduler will be looking for that location where that new container can be, on which node is you can say space available where that new container can be deployed. That particular job is what scheduler will do. Now, the controller is basically taking care of the running the cluster. It will make sure that if you have specified that I want some n number of machine learning models to be running inside pods, then if something goes down, then the controller will notice that and will take care of it, will respond back saying that okay, the pods, the you can say administrator wanted two pods to be deployed, one has crashed, let's auto heal, let's start the auto heal part. So then we have the HCD is the key value pair, which basically keeps the system states, or it basically keeps the all the internal states of the of AKS. HCD is one of the most important thing. If HCD goes down, uh, then you don't you can say your cluster is no longer there. So the cluster got created. See, it's already up. And what we will do, we will just quickly have a look at it. So I'll go to Azure. I have one of them is my backup cluster. If something goes wrong in the live session, then uh, that's what we will go back to. And this is the one which we have just deployed, this one over here. Now, what we want to do is we have deployed the cluster. Now, there is another thing. Whenever you work with you can say the cloud, you also have to you will be working with, sorry, whenever you are working with Kubernetes, you are also working with, you need some repository for images as well. You can use Docker Hub, or in Azure we have ACR, which is already there for you to use. So what I'm doing, I'm just quickly let me just quickly modify these scripts properly. So because I have changed few names here and there, so I am just basically saying that please get me the uh, credentials of this AKS cluster. And because I'm logged in right now, it will be able to get that details as such. See, I just say this, it will say that, okay, the context or the credentials are already stored in the kube/config file. Now I'm creating one ACR. I'll run this command, then I'll tell you what this command is doing and how everything is coming together in terms of Kubeflow. So let me just do this slightly carefully. Shivam Cube ACR. I think this one I already is part of my code. So I'll just say live because I think I already made that. So let me put live for the differentiation as such. And this is the name which I'm putting afterwards for login purpose. And then I just want that same ACR to be connected to Kubernetes. So I am going to put the name of the AKS cluster from here into the last command as such, somewhere here, and that one goes over there. Okay, so let me run it. I'll tell you what it is doing. So let me run this one. This takes a couple of minutes to deploy. So okay, check this out. So now we have the Kubernetes cluster with us where we will be running everything, but because the data scientists will be working with the various machine learning models which are containerized, now they will be practically requiring some place to store it. That practical place to store it can be Docker Hub, can be any third party as well. But in case you are working with, it doesn't matter where you work, you need some container repository of some type. Now in Azure, there is one service called as ACR, Azure Container Registry. So Azure Container Registry is what we are using, right? And this container registry is the repository of where all the Docker images will be pushed. So if your data scientists train any let's say TensorFlow model, then that particular image where the app code is there, all the dependencies are there, and so on and so forth, right? That particular machine learning model, that one is going to be stored in this repository. So let's say this one was for TensorFlow. Let me write it somewhere. And maybe there is another image pushed by another colleague, and this one was with XGBoost. So like this, and all the dependencies are there for it, and so on and so forth, like, right? It's for the good thing about using Kubeflow will be that we can reusability will increase. So you will notice that you will be having some steps, like maybe there is a deployment step, and that deployment step is common across multiple different uh, pipelines. As such, we'll see what is pipeline very soon. So there will be some versions over here. I'm just putting version 1 on everything, right? You can imagine like different versions are there. So this ACR is coming up right now. There is no image over there. It's totally empty. So as per my diagram, the image is yet not there. We have to, you can say, push images later on. But this ACR is there, and we want to connect this ACR to AKS. The reason we are authenticating, we are connecting is that because is later on when you run the manifest file, when you want to deploy these machine learning models, Kubernetes cluster should have rights to be able to pull from that ACR. Otherwise, we'll get errors over there, right? So we are giving those rights right now. Okay, so by now that particular ACR must already been this is already deployed over here. Now, if I just go to my Azure portal and quickly see if it is running happily over there or not. So this is that one, Shivam Cube ACR live, and this one is where in this repository section is where all the images will be pushed later on. Okay, sorry. So okay, so now if I just take you back to my file. So we haven't connected both of them yet. So I am doing this one liner which is called as like ACR login. So this will authenticate me to be able to tell ACR that ACR like I can run commands against you, right? And now I'm saying that AKS, please go and talk to ACR, get updated. And now from this point onwards, that particular ACR is from where you will be getting your images. Whenever I write slash, let's say image path, then that image path will be of that ACR. So that's what we are saying over there. It is doing its own thing. So let it do that, right? Now this is where we have already, you can say, deployed uh, we have already done the basic requirement, like the underneath requirement, like Kubernetes is already in place. Let's go to Kubeflow now, right? Let's see what is Kubeflow. Now I will just quickly, uh, as I was earlier speaking, that I have to run few commands first because it takes time for it to deploy. I will just run few commands, and then I will show you what I'll tell you what we are doing, right? I don't want to waste your time. So the basically see now when you install Kubeflow, it will have more than 30 microservices. It is pretty difficult to install it if you don't use uh, any, you can say, package manager or maybe any lifecycle manager to help us in the deployments. Now companies who work on multiple clouds, who manage or who deploy Kubernetes on multiple locations, they they use this particular client called as Juju as such, and this is from which we will be deploying the uh, Kubeflow inside Kubernetes. What it does, I'll just quickly show it to you, and I'll explain it in more depth. So let me just quickly think it through once. So I have to give the name of my Kubernetes cluster there. So I will just quickly replace this name. I'm saying that Juju client, please go and pick up this is the cluster, and you can name this cluster as live demo, right? And this is right, and then that live demo is where you have to do the bootstrapping, and then you have to add one model called as Kubeflow. This is not that model which you are thinking of, machine learning. I'll tell you what that is, and then deploy Kubeflow inside that. So these four lines will deploy that more than 30 microservice in Kubernetes as part of the Kubeflow environment. If you don't use anything like Juju, then it's gonna be something pretty uh, you can say lengthy to be able to do it. So I recommend use it. Now, okay, now something pretty tricky. Uh, because these lot of these uh, okay, great. So lot of these commands. Kubeflow is you can say is driven by the community right now. So what happens? Kubeflow may end up having few bugs, and Juju is also you can say may have a few bugs here and there. So one thing which I found is that earlier, so I when like if you so the agent which the client which I have right now is called as Juju 2.9. I recommend you use this client only. This is one of the latest client right now, and the one which is like anything which is before it 2.8 or anything 2.7 will have if you use them, then your deployment will not be successful, and you will basically end up getting one image pullback error, which means like sort of image is not found, or there is some configuration error somewhere or something like that. So please use Juju 2.9. Make sure that you install this latest one only. Otherwise you may these guides are for someone who watches this video later on. Maybe one day you are configuring a Kubeflow on AKS, then that day you will thank me. So please use that. Okay, now is it done? Okay, still doing something. So let me explain what are we doing right now. So uh, we so something like this is what we are doing. So I have this Juju client in my laptop right now, and I am asking this Juju client that please deploy the Kubeflow for me in the cluster. So the mechanism which this client uses to do that is something like a let me use few pictures from their documentation, and let me see where have I put those pictures. Okay, so these are some few pictures I took from their documentation. So this is basically that laptop is right now, that Juju client is there in my laptop, and then we have already done the so we will be doing the we will be connecting it with Azure cloud. So that is that step. And now once it is connected with Azure cloud, what it will do, we will create one model over there. Now the meaning of model is basically it's like an empty canvas where there is one-to-one mapping with AKS. Now anything which I do inside that canvas will happen in my Kubernetes cluster also. So if I say that Juju deploy the model called as Kubeflow, it will have that empty canvas over there. And afterwards, when we will say Juju install Kubeflow, it will deploy all the more than 30 microservices inside the AKS cluster. So we don't have to manually go and configure things as such. It will be able to do it for us, right? And so whatever you see right now will happen inside the AKS cluster or inside the Kubernetes cluster. Now, this particular client is pretty useful, right? So it seems to be stuck somewhere. I think it's already saying that this is already done, but it's stuck somewhere. I'll just quickly see if I can uh, go to the next line. Okay, great. So it has happened with me before, so I know it will even work, even if I break that command. Uh, so right now, so we are okay. So this is where it is creating one controller in the control plane. So what is Juju? Like, what's the meaning of it? What does it do? So if your team deploys, you can say, deploys complicated architecture or complicated microservice environment in multiple clouds. These clouds can be Azure, AWS, or in GCP as well, or maybe on premises locally in your laptop. It connects with everything as such. So what it does, it creates in the controller. It basically creates its own controller, and then with that controller, it starts controlling the environment inside the AKS or inside the Kubernetes cluster. So now once we will be able to install it, there is a concept called as charms as such. Like charms are very similar to packages, like you do pip install TensorFlow, right? So similarly, we will say Juju install Kubeflow, right? So Kubeflow is one of the package, and let me see if I can show you on their website what all details will be there inside it. Right, so I'll just quickly show their website to you, where there are multiple charms available. Okay, so this is where all the multiple charms are there. And the one which we are doing right now is Kubeflow. So we'll be deploying the Kubeflow one, this one. So it will come, so there are 26 different packages inside this particular package Kubeflow. And I just want, okay, so this will take few minutes. So if I just quickly show it to you, what all will be there inside it. I will just see if I can show you a little more details over there. And okay, I hope that doesn't go back to the Kubeflow bundle. Okay, so basically, you will be able to find more details onto their in their website also. Let me see if I click on any other version and it gives me more details. Okay, not really. So as I was saying that it comes with 26 particular packages like that. So you will notice that, like you see, there are other bundles as well. Like this is only having the Kubeflow dashboard. This one only have the profiles. This is having the visor equivalent as such. Some other options are there, but the one which we are deploying is having 26 components inside it, and those 26 components will be more than sufficient to be able to get started with the with you will be able to start over Kubeflow with it, and later on you can keep on adding more packages the way you understand, so you can do that. Now I'll just quickly go back and see whether that process has finished or not. Okay, it's still deploying the controller in my Kubernetes cluster. This may take few. Oh, done. So it just wanted a little push from me. So already done. And now what I'm doing is I'm adding that model. So this is that empty canvas which I'm putting over there. And that inside that empty canvas is where I just want the Kubeflow to be deployed. So Juju deploy Kubeflow. This is the easiest method or most straightforward method for you to deploy Kubeflow in Kubernetes. It connects with everyone, not even Azure, like nearly or literally everything. So when to use this method? If you deploy, integrate, or manage application multiple Kubernetes environments or virtual machine environments on a regular basis, then you should use this. This will really reduce your time. It will reduce that repeated process in less than, you can say, 4 or 5 commands like that, 3 or 4 commands like that. And you can deploy those frequent big environments very frequently, and it will also help you in managing hybrid clouds. It will help you in doing your day 0, day 1, day 2 operations as well. So day 0 is basically if you are doing some sort of design phase. So that's in the software design lifecycle, we have the 0 day, like the designing part, which is one of the most important part. And then the day 1, where you can say things become more creative, or where you have you bring up more details, and then day 2 type of things will be there where you do the monitoring, or you implement the solution, and so on and so forth. So day 1, day 2, day 0, day 1, and day 2 type of operations in the you can say in the context of software lifecycle management is what Juju will help you in doing. So Kubeflow is getting deployed right now, and in the meantime I just want to quickly give you the visualization of it, like what is it. So this is my backup Kubeflow. I already have deployed in one of the backup AKS cluster, and you will see that now this looks very familiar, right? So if you have joined any of my previous sessions on Vertex AI or maybe on machine learning on Azure with Azure Machine Learning Service, you must have seen these similar portals over there. All the clouds have similar functionalities. They You can create notebooks. See, some notebooks are there. You can have, you can do auto ML experiments as well. You can do hyperparameter tuning. You can also create experiments like this. We have the pipeline concept. I created one pipeline over here, which is training the convolutional neural network, and it's basically a couple of lines are there: pre-processing, training, registration, uh, some you can say four images are there right now. So there is one deploy image, there is one register image, there is one training one, and there is a pre-processing one as well. So apart from this, we can do runs. We can do the reoccurring runs as well. Any artifacts which are coming during the stages of the pipelines will also be there. So Kubeflow is that. So this is when we should come back to what is Kubeflow. So I'll just quickly use the architecture from Kubeflow's own website to just give you a little introduction into it. So if I use the picture from here, if it lets me paste that, right? So see, now what happens? Kubeflow is the ML toolkit for Kubernetes, and it is basically a platform for data scientists who wants to build, who wants to manage, who want to you can say deploy those machine learning systems. Also, even working in the ML engineering field, or even if you want to, if you so basically if you are a ML engineer or you're working in an operations team and you want to deploy machine learning systems to various environments for development, for testing and production level serving, then you use Kubeflow, the backend for the any of the clouds like that, like Kubernetes on any of the clouds or local deployments, right? So what can I do with it? I can use my any popular machine learning libraries which you are aware of. You can use everything. TensorFlow, you can use Chainer, you can use PyTorch, Jupyter can be used, scikit-learn can be used. We can do the serving as such. So you want to deploy the model. So with few lines of in the SDK or with one YAML file, you will be able to create those API endpoints where you can do request response to the models. And Kubeflow UI is what I just showed you, right? So this Kubeflow UI is what I was showing you earlier, which looks something like this. That's the dashboard of it, from where overall look and feel or the management can be done from the UI. SDK is available to do the same thing as well. You can use the SDK as well, and right. So let me just use few more pictures from Kubeflow's own website to give you a little more understanding of the various phases which are there. So whenever you're training any machine learning model, you will be very familiar with these phases. Like you have to identify the problem, you have to choose the machine learning algorithm, you have to deploy which algorithm should we go for. You experiment, you train some models, you tune the hyperparameter, and then after that you have to put that particular model in production. So then I will just put it back. So after experimentation, whichever algorithm you found to be more accurate, or the one which you found to be the one which is understanding the data better or getting trained better, is what you want to deploy. So then if you see, you transform your data, you can train your model using PyTorch or TensorFlow. You can orchestrate various stages in the pipeline, you can reuse the pipelines, you can serve the model, you can have those API endpoints, you can do batch mode predictions on multiple data points, or you can do request response based API. You can consume your model basically, right? And the MLOps pipeline will also integrate with Kubeflow, and the artifacts can be pushed from the you can say from the dev to the stage to the maybe to the production after that. And then we can also monitor the model's performance as such, like whether this model which is deployed in production, is it performing well or not. Is it basically if it is degrading, then we will be able to identify that, like if there is a data drift, if the data changed and you have to retrain the model, or you want to retrain the model after a percentage of data drift, then all those things can be done now with that model performance. So Kubeflow uh, is what is helping us do that. And let's go back and see if we can complete this is the backup one which I was showing you. Let me see if I can show you the one which we were just deploying. So I think let me just see what was the last command which we were running. Okay, we deployed the Kubeflow. Now, couple of more lines are there where, so Kubeflow is already deployed, but to open the dashboard, we still have to do few more steps. The dashboard will not be visible because it's not accessible right now. So we have to make sure that it becomes accessible. Now, there are few commands which I need to run from Bash. Uh, so I have this, I just, what I want is that the dashboard should be publicly accessible. So the way we are doing it is we are creating one ingress controller which will be able to do that for us. So it will create that path to the particular Kubeflow dashboard so we can work with it. So I'm just going to my Azure portal and I'm just running few lines over there. Oh, yeah. So I think I forgot to update the commands. So let me do that. The name of the AKS cluster was demo C cluster. Let's put it there. And the resource group was called as Kubeflow CRG. It's C is basically that Southeast Asia region of Azure near Singapore. So that one. And I want that patching to be done. I want the Kubeflow to be accessible over network. So I just want to do that. Okay. So if I take you back to my file over here, there are more things which we need to do. It's not yet done. So I'll just tell you you can say the last few commands which are there. Now, when you access the particular dashboard, you would like to access it securely. You would like to have some username and password over there in the dashboard, right? So we have to do that, like which username and which password is through which you are accessing. So these two commands needs to run, and then we will get the IP address of that ingress gateway. So it will be accessible over one public IP address. So we want to get that IP address. If I this command will actually take this particular command will take around 3 to 5 minutes to run. Like if I run, I'll just show it to you. If I run it right away, it will say not existing. So we will run it. We'll come back and we'll deploy this in. We'll run it again in maybe next 5 minutes. Then we will get the IP address of the where the dashboard will be accessible. That's what we want to get. So I will just note down all these commands. Then I'll run it in one go. Now after this, what else do I want? Is the IP which is coming from the previous step, right? The previous step from where the IP is coming, we would like to, let me show you something. Just give me a second. Let me just quickly check where did the commands go? Okay. So, okay, check this out. Now, basically, we have to set the username and password. We need the IP address from this step, and whatever IP address we will receive from that step, that particular IP address we have to, you can say to that we have to we have to do the proxy type of connection as such, and then the Kubeflow dashboard will be visible for us to do something like train a ML model over there, right? So what I have done, I have the username and passwords which are there. I sort of noted them down. Let me see in which notepad file did I do that. I am unable to find it right now. Okay. So this is where you can just put it like this. Let's say you have some username like this, and then you have some particular password like that. So that's what you have to run. So I am not showing which password and username which I am running. I'll just run it right away. And but that's how you have to give it. So that's where your username and password needs to be given in that particular format as such, right? uh, over there. So then let's see if it is already visible or not. because we just want to get that. Oh, no, not yet. Okay, we'll give it some time. And after this step, what we have to do is we just have to open the IP address. Now, even if I create the proxied connection to that particular uh, dashboard, it will still take few more minutes to open. So I'll just put this percentage for you. Let's say it will take more 3 to 5 minutes for this also to be visible for the first time. This is when you open the dashboard from the browser, right? That will take more time. Okay, now let's not wait for it. Let's go to the backup Qflow. Yeah, oh, we got the IP. Great, at the right time. Let's see what IP is there. The external IP address is still pending. It's not yet available, so I cannot run it. Let me see if it is available now. Okay, great. 20.195.332.175. Okay, so I will put that IP here, and let me see if I can run these two. Okay, so this is very similar to a, you can say, a type of proxied connection which we are doing, right? So I don't know to just, if I simplify that, that's how I can put it. Now, after this, what I need to do is I just have to open the particular IP from the browser. So from here, but oh, but the this will not show, you can say, right away. It will not be visible. It will take some more time for it to be visible. So if I just take that particular IP address, in this point in time, it will not be visible there. It will take some more time. Yeah, so let's keep this page like that. We'll give it maybe 5 more minutes. We'll just come back, refresh it, and the Qflow dashboard will open. Right. What I should do is, this is my old one, right? I'll do one thing. I'll just open this in incognito mode. I don't want the any token authentication to not happen. I'll just keep it open here. We'll come back in 5 minutes. We'll see what we are doing with it. In the meantime, let me just take you to my previous Qflow dashboard, and let's train some machine learning model. So one of the popular IDE through which, more like editor through which you will deploy your machine learning model will be using Jupyter Labs or Jupyter Notebook like this. So uh, that's what we will be doing, right? So if I click on this notebook section, you will notice that I have few Jupyter servers with me, and you can simply create Jupyter server right now, and these are running inside the Kubernetes cluster. So few default images are there, like cube lab. There is one, you can say, one on with R Studio version and one without R Studio, and other you can say images are there. You can also give your own custom image here. So that's what I'm planning to do when my Qflow dashboard will be up. That's what I'm planning to do, create one custom server, but it may take some more time. And let me just refresh this page once. Okay, great. So you can specify how much RAM and how much CPU this particular machine needs, whether you have GPU or not, any volume you want to mount over there, any like any specific type of, do you want shared memory or not. Finally, when you make it, it looks like this. See, so I'll just click on the one which I created some time back, as over here. So this is my Jupyter opening up, and I basically have this one small TensorFlow based convolutional neural network, which we will be training, right? So let's have a look at that. Let's spend some time into seeing that how that CNN layers are getting created, and let's go through the code once. And in the meantime, that dashboard will be ready, right? We'll do this there. So okay, so basically, we have few classes with us: airplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck, uh, like this, right? And we have already done the normalization on the data, divide by 255 to normalize it between 0 and 1. And now we are creating one convolutional neural network in the Kubeflow. So how do we do it? We uh, so there are some layers here. Convolutional layers are there: max pooling layer, convolutional layer, max pooling layer, another convolutional layer. and then you will see one flatten dense and one dense with 10 neurons. So why 10? Because we have these 10 classes over here. uh, you see this, we have these 10 classes, so that's why we have those 10 in the last layer. So uh, what I'll do in the meantime, our Qflow comes up. We would like to understand what's going on here. Then we will run this particular thing in our own Qflow cluster. Let me just double check whether it's ready or not. Okay, so was that not the IP address? Let me open it one more time. It's finally running. It's saying bad gateway. So let me do one thing. Let me try another browser which I may be having. So let's see. Okay, it opened in the secondary screen. Let me move it to the primary screen. And I think it needs more time. I think it's not totally done. Um, Invalid client ID. Okay, I think it's still going on. I remember running the authentication commands as such. Let me just double check whether I skip something or not. Okay, just give it some more time. I think it just needs few more minutes and then it will come up properly, right? I'll just keep it on my secondary screen. I'll keep an eye on it. When it's back, I will just let you know. Okay, so what we are doing is we are uh, basically we are okay. So we let's understand what is happening in this CNN and how are we running it. So I will just open the whiteboard again and I will move that. Let me see if I can get more space here. So let's go in this direction over here. Okay, so let me do one thing. I'll just quickly take a snip of it. Uh, Let me explain it line by line, like what are we doing in these layers? How are they coming together? So let's start from here and I'll just quickly move it to my secondary screen so I can actually have a look at that while I'm drawing. So I don't have to go back and forth in how many layers did I put earlier. And it can be a little more straight away. So check this out. So basically, there is in that convolutional neural network, we have the first convolutional layer is there. So uh, the image is having three channels RGB, right? So okay, okay, let's do it here. So the image is having three channels RGB. So this is the R, and then one green G, and that's basically blue. RGB image is there, so three channels are there, like RGB, like that. Okay, so the dimension of the image is basically 32 by 32. So the image is 32 by 32. So we are specifying that the input, if I show it to you here, see, the input image is 32 by 32, three channels are there. And then we are creating a 3 by 3 filter on top of it with 32 is the depth of the filter. So 32 is a depth filter depth. So what we are doing is that the we are running one convolutional uh, operation, convolution operation on top of it. Convolution operation is basically like you have this picture with you and you are moving that small filter over that picture like that. You just do the convolutions on top of it, you move it around and some metric multiplication happens. So the filter size is 3 by 3. So the filter is 3 by 3, but there are 32 filters over there, right? 32 filters as such. So the output feature map which will come out is going to have that 32 as the depth over there. So the output feature map is something like this. So what are we doing with convolutional operations? We are trying to understand the what is going inside the picture. Convolutional neural networks are used for those image analysis or for you can say video analysis as well. At times, it's the feature extractor. Like it extracts the feature from the from the image, like where is the horse, where is the what's the texture of the horse, where is the bird, where's the dog and the cat, and so on and so forth. So if I just quickly show that part to you, you will notice that I have this you see, like the output is 30 by 30 and 32 over there. So this goes here, this is 30 by 30 and this is 32, right, like this. So the depth is 32. So once we have done that, we are, after this we are basically putting one max pooling layer. So max pooling, and that to the filter size is 2 by 2, like pooling size is 2 by 2 as such. So what max pooling will do, max pooling does the averaging, like it max pooling actually does the maximum number it takes out. But the concept is like it is trying to find the features which are most important, like the dominating features. It's not trying to find the features which are not we can say dominating. Like if there is a cat versus a dog, then what features are the most dominating, by which we can differentiate between this versus that. So that type of information it is trying to extract right now. So what this pooling will do, let's say if the values over there was something like this, maybe 9 and 8. So if you do max pooling, it's going to take that maximum value like 19 as such from the input feature map, and it will create its own output feature map. So here those dominating features will be there in this output feature map. So it's not 3 by 3. I'll just quickly see in the example what was the output size, and I'll put it there. But this is happening, this will happen on that line. So the output size is 15 by 15 and 32. It's gonna shrink the entire uh, feature map by half. So this is why you also do padding. If you have a very deep neural network, then you would also like to do padding over there to be able to make sure that it doesn't shrink before your network is able to learn it. So 32 is the depth of it. And then if we go back, there is another 3 by 3 filter and 64 and one max pooling. Okay. So on top of this feature map, there is another convolutional layer is there, and it's the filter size is 3 by 3. And this time the output which comes out to be is, you can say, further is short, but there are 64 is the depth of it. So you can say that it's learning uh, way more, uh, it's extracting way more features from the input image than the previous layer was doing. So just like you guys do, like you first generalize and then you go in more depth into some topic as such, and you keep on going in depth and like that. So that's similar type of concept is what you can relate to in this scenario. So 13 by 13 is the output and 64 is the depth. So this feature map is left as 13 by 13. Feature map is that, like when you do the convolutional operations, like the output what comes out is that feature map where the features have been extracted. Now on top of it, what is going on? Another pooling layer, 2 by 2, and another max pooling layer as such of 3 by 3. So let me just put it in a smaller, you can say, maybe just like this, that there is a 2 by 2 max pooling over here. So the output will be here. And then on top of it, there is one more. Then again, there is another convolutional layer with the filter is 3 by 3, which is doing the convolutions on the data in that point in time. So uh, that is going on as such. And if you notice that, uh, okay, then after that we have one flatten layer. So let's see the last output. It was 4 by 4 and 64. So let me see till where have I done it. So then there is another layer of 4. This is 4 by 4. That's what is left. But 64 is the depth. So the depth of the feature map is 64, and this is 4 by 4. Right. Now on top of it, what we are doing is we are doing that. We are putting one flatten layer, and this flatten layer is having 1024 must be the final, you can say, output from the, you can say, the number of neurons as such, or 1042 is the number of features which are finally extracted from the entire you can say images. So that's that 1024 and 64 and 10. So let me explain that part. So here 1024 neurons are there in this flattened layer. So these artificial neurons are 1024, right? And the type of mapping is also dense as such. Let me okay, so like this, then 64 dense. So this will be 64, and then finally 10 will be there. So it doesn't looks like 10. I'm just trying to make that 6, 7, 8, 9, and let's put one more 10. So this is 10 over here, right? And everything is dense. So in dense, all the neurons from the previous layer. So to every neuron, you can say every neuron from the previous layer is connected. So these are dense. This is dense type of connectivity right now. So I'm trying to add every neuron to every neuron, but in my diagram, it may not be looking so dense, but I am pretty sure you already know what it means. So, uh, right, this is that dense connectivity. And this is that CNN layer, CNN model, which we are training in Kubeflow. So the output will be coming on this layer like this, right? 10 classes are there. Now let me quickly let's deploy this, right? Let's see. This is what is happening in that convolutional neural network, and let's run it. So I will just quickly see if the Kubeflow which we deployed, is it ready to be used, or does it need more time? So it needs more time. It is still not totally deployed. So this is where you have to be patient. So what I'll do, I'll go to the one which I have already, which we are using here. And here we will create another new server. The reason I'm creating another server is just, I just want to show you that particular step of server creation. So small letters. So please just put small letters there. Okay, so this is what we would have done. Like we would have gone for this, would have gone for custom images, and then there is a custom image which I want, which is available in GCR in Google's repository. It is already having TensorFlow installed, so we don't even have to install it. I am just looking for that, the you can say the URI of it. Let me see where it is. Okay, found it. So this is from where we are pulling the particular, uh, you can say we are pulling the particular uh, the image from. This is basically Kubeflow public images, TensorFlow 2.1.0 notebook CPU. It runs on CPU as such. Similarly, images will be there for GPU versions as well. So you put it over here. You specify how much GB RAM and so on and so forth you want. So I am saying 2 CPU and give it maybe 4 GB RAM. My AKS cluster should be having sufficient RAM right now. If something goes wrong, we'll check it out. But it should be having some, you can say, little bit of sufficient RAM for this to execute in this point in time. We'll see if it doesn't get created. Right. So in the meantime, if you have any questions, then let me know. Okay. So it seems to be taking few more minutes to run. Basically, it will. Oh, sorry. Let me go back. It will just come up in few seconds like that, few more seconds or minutes like that. And so if you have questions till now, let me know. So uh, let that come up. So that's CNN, or I have sort of showed you how it looks like, right? So let me just go back to my existing notepad, and I'll just put it over there. And I don't want you two guys to wait on this. So right. So okay, then okay, let it come up. So this, let's go back then. Okay, so the notebook is anyways open here. If I just show it to you again, let's run it again, the same notebook. So right, so this is where we are creating that convolutional neural network, and it is having these layers which I was earlier describing it to you, that it will have that convolutional, then pooling, then another convolution pooling, and it extracts all the feature, and then we do the classification in the end, as such, in the dense layers, and it is mapped to those 10 outputs. So because why did we had 10 at the end? Because that's the number of uh, final outputs that we had. Now so in the meantime it is running. Let's, oh great, so if I just go back, the previous the Kubeflow dashboard which we were creating also came up. There was one slight mistake which I made. That's what I was thinking of. I'll just tell it to you. I didn't do the port mapping. It was supposed to be 80 here, right? That was the error. So those who are watching this video maybe later on one day configuring, put that 80 like this. So I just placed that, and I was just checking it out, and the page opened. Let me see what was the username and password which I have given. Otherwise, I have to show you how to reset the password as well. Uh, so username is pretty straightforward, and the password is here. Okay, so this is the brand new Kubeflow dashboard, and this is where we were planning of making that. So let's see. I'll just put it here, and now you already know the steps of what needs to be done. So this is what I was planning, that we'll be making one notebook server. Before I forgot to put the port mapping. Okay, so this is the new server, and small letters, it takes the first letter as capital. Okay. Because of the CNN layer, let's give it 4 GB RAM, otherwise it will take more time to train. And because the cluster which I'm deploying is also pretty small right now, so I don't want to put a very big size over there. And okay, now in the meantime this will take some more time to run, but you got the understanding of how does it look and feel like. So this is model is already training. The epochs are going on right now, and we will have the accuracy curve here, uh, you can say, in some time. So let it run. In the meantime, I'll tell you more about which what other things which we are doing. And so I have few more things already, you can say, sort of the demo is ready for you guys. So I'll tell you the other features of, in the meantime, it is training. Let's see the other features which are there in Kubeflow, like what other things are there. So it also contains KF serving over there, Kubeflow serving. See, when you want to deploy your machine learning model, you have to open the endpoints. Now, from the point of view of data scientist, doing a canary deployment, doing a rollout, doing a maybe upgrade of the models, maybe doing it for the first time also will be slightly difficult. That's not what they the networking part, how will the traffic coming, the load balancing part, uh, that is pretty complicated. So in Kubernetes, so what KFServing is doing, it is creating that abstraction layer on top of everything. So you just tell which model, it will deploy it for you and will tell you the endpoint. If you want to one instance of it, you want 5 instance of it, it will do the load balancing for you. So if you end up doing the basically if you end up like everything is abstracted now, it automatically scales out, scales in based on the configuration. So this KF serving is what we are using, and I have this one reference link with me, which I will use to show how straightforward it is. So this is where the using KF service, the inference pipeline is getting deployed. So you just have to specify like that, like which model are you using, in which namespace do you want it to be deployed, uh, which particular you can say where is the storage UI as such, and then you can come and you can say the kf serving dot create, and then it will be able to deploy that particular model, and then you can use that the IP addresses of, you can say, the URLs on where it is deployed for doing your predictions as such. So you can do the you can also do canary deployment over there. You can say that if like maybe 25% goes to the new model and 75% goes to the previous one, and then over a period of time the you are doing the switch to the new model which you are deploying. So KF serving comes along with Kubernetes as such. And there is one more thing in which I wanted to show you, uh, which is basically part of my cluster. It is over here. If I click on the AutoML, you see this Katib as such. So we have Katib, it does the hyperparameter tuning for us. It also searches the neural network architectures. So hyperparameter tuning is something where it takes time, and it is something which is very important for the purpose of that, for understanding how well that machine learning model will end up being be. So if you have a search space where the parameters are there, then from that, should we do grid search, should we do random search, or do you have any Bastion, you can say, uh, uh, or you can say sorry, not Bastion, uh, basically, like, what type of search should I do uh, from that grid search is what Katib can help me do it. So if I click on the hyperparameter tuning, you will see that it provides me with one UI as well, and it also provides me with the uh, you can say the YAML file as well, like which one do I want to do. So like how many parallel tries should be there, maximum number of tries will be 12 right now in this example, and if 3 are failed, then simply exit, the exit criteria will be there. So then what should I do? Like, should I maximize or should I minimize? So if error is there, you would like to minimize. If you have some sort of accuracy over there, you would like to maximize it. So right now it's saying the training accuracy, the maximize the accuracy. The goal is to receive dot 99. If you hit this 99% accuracy, then you can right away, like, it will exit out. So what type of algorithm do I want to have? Like grid search, hyper random search, hyperband, any base optimization I'm doing on top of it, and uh, so multiple algorithms based on the requirement as such. So right now it is randomly. Random is like you from the search space search randomly pick up, and when you are able to have more. You able to you find some parameter around which hyperparameter around which you are getting better accuracy. You can do a more uh, grid search around that. Early stopping criterias, then what are the criterias? Like uh, if there is a iterations are going on, then if the model is underperforming then particular number, then just exit it. Like, don't train it, it's not going to work out in the end. So don't go for it. So these type of settings is what I can specify over here. I can put it as part of Katib, and then Katib will be able to train the hyperparameters for me. So this is something which I wanted to also put through, which Kubeflow provides. And the pipelines which are there, this is like if I just sort of do a quick recap. So Kubeflow is that toolkit which abstracts away the complexities of Kubernetes from the data scientist, and which makes that serving way easier. It does the release quicker, and that's how we sort of configure it up. If you have questions for me, then do let me know. And this is what I had planned for the session. This one is a sort of a shorter session than others which we do. So this is what I had planned for the session. And if you have any questions for me, then I'm here for you for that to be answered, right? So please go through it and put your questions in the chat window. And do let me know, is Kubeflow something which which you already are using? How do you like it? Do you now do you understand what's Kubeflow? What are the various type of things it does, right? And how do you deploy the dashboard of Kubeflow? How do you deploy the Kubeflow in your Kubernetes cluster? How to make the Kubernetes cluster, and how to train your convolutional neural networks inside that? So do let me know about that, right? So I'm put your questions in the chat window. I'll answer it.